week 13. And there we have only 3 more lectures, including this one. So today, we are going to go look into yield criteria. And yield criteria is not difficult. Okay, it's just another thing to consider when you do analysis. Okay, so we are going to go into yield criteria. We're going to look at ductile material first. Okay, so yield criteria. For ductile material. So the emphasis over here is ductile material. So what do I mean by ductile material? Okay, so ductile material what do I mean by ductile? So it's low to medium carbon steel. That's one of them. Then you also have your titanium, copper, aluminum, and nickel. So these are classified, what we classified as ductile material. So these are just names, right? So as engineers, what do we mean by ductile material? And I can give you a simple way of looking at it. So for ductile material, okay, you have to look at values. A good indicator is the yield strength is a lot smaller than the ultimate strength. Okay, so this is what we mean by ductile material. Whereas if we look at brittle material, usually, okay, the yield strength is approximately the same as the ultimate. Okay. So by looking at magnitudes, you can more or less guess, is it ductile or brittle? Okay. So the yield criteria, okay, the yield criteria is used to determine the transition between elastic to plastic region. Okay. So for ductile material, there are two commonly used criteria which I will teach in this class, and they are maximum. So the first one, number one, is known as the maximum. Sorry, maximum shear stress criteria. and is also known as Tresca. Okay. So how I like to spell Tresca is I use the symbol tau, Tresca, because this symbol is also the symbol for shear stress, yes or no? Okay, that's how I get to remember, right? I transform the T to the shear stress symbol, and the second most commonly used ductile material, U criteria, is known as the maximum distortion energy criteria. And this is what we call, usually the name comes as Vomisis. Okay, so these are the names of the creator of the theory. Okay, so I'd like to focus today. We'd like to focus on the maximum shear stress criteria, and then on Thursday we're going to look at the maximum distortion energy criteria. Okay, so let's look at the maximum shear stress criteria, which we also call as Tresca. Okay. So there are two formulas, or there are two. The criteria has two formulas. One is where tau max is equal to stress U over 2. Okay, where so this is our first relationship for Tresca. Okay, so this is where this is known as our equation 1. All right, where sigma y is our U strength. Okay, and this is, as we already know, this is a material property. Okay, this is a material property from experimental unidirectional test. Okay, so it's a material behavior. Okay, then the other one, okay, the other equation that I'm going to write for you is tau max also is equal to absolute value of the maximum stress divided by 2. Okay, so you can see both of them have different what we call they how we determine them are different. Okay, equation 1 is a material property. Equation 2 is through structure analysis, where sigma max is obtained from structure analysis. Or another term I want to use, it can be also calculated. Okay. So in equation 2, you can see in equation 2, okay, in equation 2, now one of the principal stresses, okay, one of the principal stresses is equal to 0. And the other can either be positive or negative. Okay, or negative. Okay. So if I were to sketch this on a Mohs circle, okay, I'm going to draw a Mohs circle. Hold on. Okay, we're going to draw Mohs circle. So on our x-axis, this is our normal stress. And then on our y-axis, okay, this is our shearing stress. Element rotate clockwise, element rotate anti-clockwise. Okay. And I'd like to highlight that over here, I'm going to put our stress yield inside here. Okay. So at this point over here, this is our stress yield. Okay. And over here, this is our minor stress yield. And over here, this is our tau max is equal to stress U divided by 2. And the one at the bottom, this is our negative tau max is equal to minus stress U over 2. So we have done this before when we do 3D Mohs circle. Okay, we draw our operating bracket. Right. And then, so all this stress use is our equation number 1. And then for equation number 2, okay, so over here is our 1-hour point. Okay. And then over here, this is our stress max. Okay. Or at the first dot is our stress A. Our second dot is our stress B. Okay. Where stress A and stress B are the principal stresses. Okay. So they are calculated, and then now we construct our Mohs circle. Okay. Now we construct our Mohs circle. And this value that we calculate in terms of shear, okay, this value that we calculate over here, this is equal to our stress max divided by 2 and this is our tau max. And this is from equation number 2. Okay, equation number